Good evening, everyone. Welcome to the doubt clearance session for week 5. Today, I'll be running over the concepts discussed during week 5 lectures, and also I would solve a few problems which will help you understand how to tackle the problem of variable selection, or rather how to have a model selection approach. Okay, so let's get started. I hope my screen is visible to you and I am audible. Alright, then let's get started. So, what have we learned so far? This is the overview of whatever we have learned so far till week 4. So, we learned how to fit a simple linear regression. To fit a linear regression, the aim is to minimize the residual sum of squares. And what is the technique for it? So, the technique is we write down the residual sum of squares and then we differentiate with respect to the unknown parameters in the model, and then we equate it to 0, right? And then by solving, let's say if we have p unknown parameters and we have p equations involving the beta p's, then solving all of them simultaneously gives us the estimate of beta, which is beta hat. And we also learned a few properties of these regression coefficients, like they are unbiased, what is their variance, and their distribution. So standard assumption is that it is normally distributed, and so that's one of the assumptions that we make when we go ahead for testing. And so then we see that if initially we assume that the errors are normally distributed with uniform variance, that is the homoscedasticity assumption holds. If that holds, then the regression coefficients are also unbiased. Even if they don't hold, they are unbiased, and yeah, and they follow a normal distribution. And also we test the significance. We have learned how to test for significance of the regression model as a whole. That's an F statistic. We've seen how to find out the degrees of freedom of that F statistic. So that depends on the number of parameters that we are fitting the model with. And then we've also learned the testing of hypothesis of individual regression coefficients. Like if we want to know, given a set of p variables, if my x p plus 1 is significant or not, that is usually tested with a t-test. And also we have seen if a subset of the entire set of regression coefficients, if we want to test for that, then we have seen how to use the extra sum of squares technique to go ahead and test the significance of that particular subset. Okay, and on top of that, we've also learned how to calculate confidence intervals and prediction intervals of the parameters of interest, like beta, and also the expected outcome confidence interval for those kind of things. And then during week 5 we had ventured into variable selection, where these are our 4 primary objectives. That is, we want a model which predicts well, which approximates the true relationship between the variables, and we want lesser variables to explain larger variations. What I mean to say, larger proportion of variation in the response variable. And we want to, in essence, we want to use a reduced model with less parameters, but we want the good properties to hold, like we want property 1 or objective 1 and 2 to be there, but with lesser number of variables, so that the model is simpler and easily generalizable. Okay, so in order to do that, we learned that how we can do variable selection. So the first one is we consider all possible regressions, and then we base our decisions on 4 certain matrices. The first matrix is R square. Okay, so we take that variable where we consider that subset, like first we take one variable, okay, get the maximum R square for each of the models that fit one variable. Okay, then we take models with two variables, then find out the maximum R square that is there, uh, that is borne by two of the variables, and then we keep on doing like that. So then after that we take three variables, fit a model, combinations of three, we fit the model, and then we see which is giving me the highest R square, and then make a plot, and then we finally select that model which where the increase in, so R square is going to increase as we keep on adding variables. So we stop at that position where further increase in R square is not what do I say, when further addition of variables is not making significant changes to the R square value. Okay, similarly, because R square keeps on increasing with the number of variables, and we sort of want to we don't want that, we want to have a trade-off between model simplicity and the proportion of variance explained. So instead of R square, we could use adjusted R square, and the formula, and the procedure remains just the same. First we fit one variable models, then we fit two variable models, then three, and then four, then take the maximum of adjusted R square among those four categories, and then find out that particular uh, model for which the maximum adjusted R square is not increasing significantly, and then within that and then that would be our preferred model. So instead of selecting adjusted R square, we could also go ahead and work with the MS residuals. And in MS residuals, what do? We try to select that model. So for each of those categories, one variable group, two variable group, three variable group, four variable group, we take the model, we plot the minimum MS, the model giving, the minimum MS residual within that groups, and then whichever is the lowest, we take that. We take that variable where the decrease is not significant, and then the lowest MS residual would be our variable of choice. And then we also use malus CP. So we want to have a model where CP would be equivalent to P. Okay, and we want P to be less than the total number of variables. Excuse me. Yeah. Excuse me. So we want approximately CP equal to P, but P should be significantly less than K. Okay, so these were the criteria that we learned in the previous class. So now what I'm going to talk about is actually sequential selection. Instead of fitting all possible regressions, because you can understand, if I have, let's say, a very large number of variables, let's say I have 10 variables, okay, and then fitting, sorry, how many, yes, just give me a second. Okay, uh-oh, just give me a second. Yeah, so if I have number of variables very large, let's say, okay, so then we'll have to fill this all possible, fitting all possible regressions, we'll have to fill a large number, okay, but we don't want to do that. All right, so there may be situation where it doesn't really make sense to use your resources to fit all possible regressions and then use these techniques to decide which is the best amongst this all. So when that doesn't seem to be a feasible option, or even otherwise, you can also prefer a sequential selection, because the thing is, just to um, explain the proportion of variance better, you wouldn't want to include something which is not that significant and which is not contributing much to the proportion of variance explained. Okay, so it is another way to go about this thing is sequential selection. Okay, and um, there could be three ways you can do it. It could be a forward selection, it could be backward selection, and it could be stepwise selection. So just to brush up the concepts, so what happens if I do a forward selection? How do I go about a forward selection method? So let's say I have x1, x2, x3, x4 and x5, 5 variables. All right, so the first criteria is I am going to fit y equal to beta naught plus beta 1 x1, y equal to beta naught plus beta 2 x2, y equal to beta naught plus beta 3 x3, y equal to beta naught plus beta 4 x4, and y equal to beta naught plus beta 5 x5. Okay, and then I'm going to test for this thing, significance of beta 1, beta 2, beta 3, beta 4 and beta 5. All right, so that would be my f1 given intercept model, f2 given intercept, f3 given intercept, f4 given intercept, and f5 given intercept. Okay, so among these I am going to select maximum whatever is coming. Okay, 1 given this thing, 2 given this thing, 3 given this thing, 4 given this thing, 5 given this thing. Okay, so first step is selecting the maximum, and then I'm going to check out if this max thing is greater than the f in, that is the critical value. So f in would have would be f 0.05, if or rather I should say f alpha, which is the upper alpha point, usually we take alpha equal to 0.05, but this could change. Keep this in mind. All right, so this one, and the degrees of freedom would be 1, and this would be n minus, how many are we taking variables? So unknown parameters for each of these would be 1 and 2. So this would be n minus 2. Alright. So if we have a maximum of this thing and that is greater than the threshold, which means that whichever of these is maximum, that corresponding variable is quite significant, and it is most significant among the others. So then let's say if f31 is most significant, then we add f31 to the model. So then let's say if f3 intercept model is the max thing, then what do? Step 2, we add beta naught plus beta 3x3. So this then becomes my base model. Okay, and then we proceed to add others. So we can have beta 1 x1, we can have y equal to beta naught plus beta 3x3 plus beta 2x2, then we can have plus beta 4x4 plus beta 5x5. Okay, so then okay, so now again we are going to find out maximum of if 1 given 3. Okay, so we are testing the significance of x1 given x3 is significant, if 2 given 3, if 4 given 3, if 5 given 3. Okay, and let's say 2 given 3 is the maximum. Then if 2 given 3 is the maximum, then we find out if f2 given 3 is greater than the f in at step 2. Okay, sorry, so f in at step 2 becomes what? It becomes, so then this thing at this step becomes f alpha, which would be 0.05 again if nothing is specified, but it could also be 0.01, so be very careful here. All right, so it is f alpha, and then first df remains 1, and the second df is n minus number of parameters tested, so this would be 1, 2, 3. Okay, and if this holds, then this will get added, and if it does not hold, then that is where my forward selection is going to stop. Okay, as long as we have something, as long as the maximum among these exceeds the threshold, those will be included. The moment we find that none of these, the moment we find that the maximum among these, so if maximum doesn't exceed this, then it's quite natural that the others will also not exceed this threshold, so we are not going to keep on adding them in the model. So if this situation is true, let's say if f2 given 3 holds, then what do? Then we move on to step 3. Now we have our updated model, y equal to beta naught plus beta 3x3 plus beta 2x2, and then we are going to fit 3 models now. So it will be beta 1x1, beta 4x4, beta 5x5. Alright, beta naught plus beta 3x3 plus beta 2x2, this would be beta naught plus beta 3x3 plus beta 2x2. Okay, Now again let us find out the maximum of f1 given 2, 3, f4 given 2, 3, and then again f5 given 2, 3. Alright, so now let's say among these I find that this is the maximum. Okay, so this becomes f5, 2, 3, but it is less than the this criteria f in, which is f alpha upper alpha point 1 n minus 1 2 3 4, because we have 4 unknown parameters. Alright, so if this maximum is less than this thing, so then we stop. Alright, then we stop, and this becomes our final selected model by forward selection. Okay, so this is the stopping criteria. Then is it okay? Yeah, so very similarly we'll have backward selection as well. All right, so similarly, very similarly, we'll have excuse me, backward selection. Okay, just give me a minute, I need to plug my device. Just a second. Okay, yes, so where were we? Okay, so we were discussing how backward selection would work for us. So the procedure remains the same, but instead what do? In step 1 we fit the full model. Okay, so we would fit y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4 plus beta 5 x5. Okay, so we fit the full model, and then we find out the significance of each of these given the others. Okay, so first we find out f1 given 2 3 4 5, then we find out f2 given 1 3 4 5, then we find out f3 given 1 2 4, 5. Then we find out F4 given 1, 2, 3, 5. And finally F5 given 1, 2, 3, 4. Okay. So we find this out. And then we take a minimum. Okay. So minimum of these we take. So let's say F2 given 1, 3, 4, 5 is the minimum. Then what do? We check if minimum is less than, so if this thing is less than the F out criteria. So what would be F out? This is also the upper alpha point. First DF would be 1 and second DF would be n minus. So how many we have? 1, 2, 3, 4, 5, 6. So it would be 6. Okay. So if the minimum of these is less than this thing, means that this is the least significant one. So we can maybe do away with it. So let's say this condition holds and this is true. Then what do? We discard x2 from the model. So then what do we have in our second step? So in step 2, what will we have? We'll then have a model y equal to beta naught plus beta 1 x1. x2 is gone. Then we'll have beta 3 x3 plus beta 4 x4 plus beta 5 x5 plus epsilon. Okay. So in all of these models I am forgetting epsilon. Don't do that. This is always there. It's not a deterministic model. So we'll always have some epsilon term over here. Okay. Fine. Yeah. So in step 2 we'll do away with beta 2 and then we'll try to find out what are the other variables that we can do away with. Okay. So now in next step we'll consider f1 given 3, 4, 5, f3 given 1, 4, 5, okay, then f4 given 1, 3, 5 and f5 given 1, 3, 4. Okay, and then again we find a minimum. So let's say if this is minimum, so minimum is f3 1, 4, 5. We have to check if this minimum is less than f out. So f out will be f alpha 1 n minus 1, 2, 3, 4, 5. So if this holds, if true, then we'll discard x3. Okay, so let's say this is true. Alright, then what do? Then we move on to step 3. We discard x3 and then we fit beta naught plus beta 1 x1 plus beta 4 x4 plus beta 5 x5 plus epsilon. Okay, now similarly we fit 1 given 4, 5, 4 given 1, 5 and 5 given 1, 4. Okay, we take the minimum. Alright, let's say this comes to be minimum 1 given 4, 5 and we see this is greater than if out, that is if alpha 1 n minus 1 2 3 4. Okay, so this is there, the minimum contributing variable is also significant. Then this is where we stop, and then our final model is this one, y equal to beta naught plus beta 1 x1 plus beta 4 x4 plus beta 5 x5 plus epsilon. So this is where we stop at that point. Is it okay? Now, this was forward or backward. So if you can appreciate or realize this, while fitting forward and backward, we are not keeping a track of the variables historically. Like once you're in the model, you're in, but once you're out, you're out. There is no, second chance that is being given. We don't know if in the presence of subsequent variables added or removed, the variable that we are adding or the variable that we are removing, in presence of others, whether they are significant or not. Okay, so this is one drawback that we have for backward and forward selection. Like for example, if let's say let me go back to the house example. So let's say I assume that price of a house depends on certain factors. Now if statistically it turns out that price of a house depends on number of windows, right? So then we take number of windows as a factor. Now the next thing comes up, given the number of windows, price of a house is also significantly affected by the floor area. Okay, so then we include floor area. But then once we include number of windows and number of floor areas, we are not testing whether, given that we have included floor area, how significant is or how important is number of windows when we are conditioning on the floor area. So we are not going back and checking whether the models that we have excluded or included, more specifically whatever remains included in the model, whether that still remains significant or not. So in order to do that, what we excuse me, so in order to do that, we take the help of stepwise regression. So here what is done is that we go back and forth. Okay, and then we see if the variables that are there in the model remain significant at every step after inclusion or deletion of the other variables. Alright, so this is what we do. So this will combine your forward selection plus the backward selection method, and we'll go back and forth, and at every step we are going to check if inclusion or deletion of the other variable is actually, I mean, whether after inclusion we are having all the variables that are there in the model remain significant or not. Okay, so here if we have something like this, let's say y equal to, so we have x1, x2, x3, x4 and x5. So first we'll fit this thing, beta naught plus beta 1 x1, y equal to beta naught plus beta 2 x2, y equal to beta naught plus beta 3 x3, y equal to beta naught plus beta 4 x4, y equal to beta naught plus beta 5 x5. Okay, and then we find out the maximum of f1 given intercept, 2 given intercept, 3 given intercept, 4 given intercept, 5 given intercept. Okay, so let's say this is my maximum. Okay, f2 given intercept, then we include f2, we include x2. So in the first step we do not check whether x2 is fulfilling the significant criteria or not, because it's no point checking that, because it might happen that upon inclusion of other variables this doesn't remain significant. Okay, so usually we'll just include x2. So this, if this is step 1, in step 2 we are going to include beta 2 x2, and then we are going to check, we are going to see if we can fit others, beta 1 x1, beta 4 x4, beta 5 x5. All right, plus epsilon. Okay, and then again what do we do? Now that we have fit this one, then we are going to check which of these would explain, I mean would be significant given we have f2. All right, so what do? We take, so we are going to find out sorry so we are going to plot f3 given 2, not plot, we are going to find out f3 given 2, f1 given 2, f4 given 2 and f5 given 2. Okay, so once we do that, then we so once we do that we get the maximum. Okay, and then let's say this is the maximum, f1 given 2, and we check if this is greater than the f in criteria. Okay, that would be f alpha 1 n minus 3, because we are fitting 3 models, 3 unknown parameters. All right, so if this holds, if this is true, then we include x2. All right, or rather we include x1, sorry, we include x1. Okay, now here comes the forward and backward, back and forth. So up until now it was forward selection. We added one, then we deleted, we added one, then we added another one, and now I am going to go back and check in step 3. So we have this beta naught plus, what do we have here, beta 2x2 plus beta 1x1 plus epsilon. Now this one was, let's say, 2a. Let me just name it as 2a. That would incorporate forward selection. And then let me go to step 2b, which would implement backward selection, which will ensure that x1 remains significant even, or rather x2 remains significant upon addition of x1. So we know that if 1 given 2 is greater than the f-in criteria, so this is significant for this model. Okay, so this thing is ensured in the previous step. This is ensured in previous step. So now we need to ensure that f2 given 1 is also greater than the f-in criteria. Okay, so this is what we do then. So then we test for h naught beta 2 equal to 0 in this model. Okay, and the test statistic would be f2 given 1, if that is also greater than the f-in criteria, which is if alpha 1 in minus, how much would it be, 1 2 3. Okay, so if this is true, then we'll keep x2 x1 and then proceed to step 3. Okay, and then the same thing will keep on happening. So let's say in step 3 we are going to add, so we have beta 2 and beta, so this part is fixed, y naught plus beta 1 x1 plus beta 2 x2. Now we again would, let me name this as 3a. So here again we would try to incorporate forward selection. Okay, so now beta naught, beta 1 x1, beta 2 x2. Now I could add beta 3 x3, beta 4 x4, or beta 5 x5. Alright, this would be beta naught plus beta 1 x1 plus beta 2 x2, y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus epsilon plus epsilon plus epsilon. Okay, now same thing, we want to have maximum of f3 given 1 2, f4 given 1 2, f5 given 1 2. Okay, let's say we have this thing f4 given 1 2, so then we check f4 given 1 2 is greater than the f-in criteria. At this step it is if alpha 1 in minus 1 2 3 4. Okay, so if this holds, then we'll proceed to step B. Okay, so this one is step 3b. Alright, so here now what we have, we'll include beta 4, so we'll have beta naught plus beta 1 x1 plus beta 2 x2 plus beta 4 x4 plus epsilon. Now again I'm going to apply backward. Alright, then what do we have here? We'll find out again if 1 given 2 4, if 2 given 3 1 4, if 3 given, or sorry, if 4 given 1 2. Okay, then we'll find out the minimum. Okay, let's say if 2 is the minimum. Okay, if 2 given 1 4, if this is less than if out, that is if alpha 1 1 2 3 4 n minus 4, if this is true, then we are going to again discard x2. Okay, and then we'll again test for if 1 given 4 and if 4 given 1. Okay, and then if we find that okay, those two remain significant, then we are going to go ahead and add x3 to the model, and then we'll see, and then we'll continue. Okay, so this back and forth will continue. It will continue as long as all coefficients are significant in the model. Okay, so given in the presence of all other variables, all of these variables remain significant. So so we'll go like this from step 3a 3b. So let's say we reach a stage where we have step 4a 4b 5a 5b. Okay, and we reach a stage where we have a model y equal to beta naught plus beta 1 x1 plus beta 3, no, beta 3 is already out, no, beta 2 is out, right? Yeah, so we can have something like beta naught plus beta 1 x1 plus beta 3 x3 plus beta 5 x5 plus epsilon. Okay, so if after 5b we land up at this stage and we find that if 1 given 3 5, if 2 given 3 5, and if 3 given 1 5, and we take the minimum. Okay, so if we find that the minimum is greater than the if out criteria, which is if alpha 1 n minus of this model 1 2 3 4. So if we see that this is true, then we stop and we declare that okay, this is the final model by stepwise regression. All right, so one thing that we should note in our mind is that if we have model 1 from forward, we can have model 2 from backward, and we can have model 3 from stepwise. Okay, so we have to note that model 1 2 and 3 may or may not be identical. Okay, what I mean to say is that forward may give you a certain result, backward may give you a certain another result, and stepwise will give you certain another result. So based on the kind of problem and based on your judgment on the most suitable model, I mean, most suitable technique for model selection, you could decide whether you want to go ahead with a forward selection, a backward selection, or a stepwise selection, and then finalize on your preferred choice of model. Okay, but do note that all of these will not yield, I mean, may not yield the same results. It might happen for certain cases, then we are, I mean, then that's golden because we can just go ahead with that model. But in case we find ourselves in situations where one of the models is giving me one result and another model is giving me another results, then we have to use our own judgment to find out whether the model the model that we have from each of these, which of each of these selection procedures, which one looks most viable in terms of, uh, it could be in terms of cost, it could be in terms of significance in the field of study where you're actually applying these variable selection techniques. All right, so maybe model 2 is giving me a good model but with a variable which doesn't seem like very relevant to my field of study. Like I would, if I have a certain application in mind and I find model 1 and model 3 giving me variables which uh, you know seem very plausible with respect to the kind of problem that I'm trying to address, then even if model 2 gives me a better results, I would still go ahead with model 1 and model 3 just because the variables that they've selected seem more plausible in a real world scenario. So so all I'm saying is it it, it might happen that the models are different, and then you have to use your own judgment to select, to decide on which of the models you want to go ahead with. All right, so with that I am going to proceed to a few problem solving. I'll solve a few questions, and then if there are any more questions we can discuss it right now. Seems like there's no one. All right, so let's start with the problems. Okay, so this is a variable, or here they have given this thing. All right, regressor variable, so we have the SS residual for all of these models, and uh, we know that a beta naught term is included in all the models. Okay, so now the question is, we have four variables. This is the full model, this is the model only with the intercept. All right, so the regressor variable that will be eliminated at the first iteration of backward elimination. Okay, so backward elimination means that the model that we are fitting is a full model. So what we have is this one. All right, so we have beta naught plus beta 1x1 plus beta 2x2 plus beta 3x3 plus beta 4x4 plus epsilon. Okay, now we have to find out if 1 given 2 3 4 2 3 4, if 2 given 1 2 4, and if 3 given 1, sorry, if 2 given 1 3 4, F3 given 1, 2, 4. So let us just find out. Alright. So F1 given 2, 3, 4 means what? Means that we have this model, this full model, beta naught plus beta 1x1 plus beta 2x2 plus beta 3x3 plus beta 4x4 plus epsilon. And the hypothesis that we are testing is that beta 1 equal to 0. Alright. So then the test statistic is what? This is sum of squares due to regression from the full model minus sum of squares due to regression from the reduced model by this, by, since we are testing 1, so 1, and this would be ms residual. Alright, so this is usually the test statistic in terms of sum of squares due to regression. Okay, but if we want to write it in terms of sum of squares due to residuals, then we'll have SS residual from the reduced model minus, because this is SST minus SS res. So always remember SST equal to SS regression plus SS residual. Alright. So if this is the formula in terms of regression, then in terms of residuals, it will be just, it will get flipped. So we would have SS residual reduced minus SS residual from the full model by MS residual. Now we just have to find out from this model. So this is reporting. So the reason why I wrote it in terms of SS residual is that this is reporting SS residuals. Alright. So now what do we have here? SS residual is this thing, 47.86. Okay. So SS res full is 47.86 and DF is how much? DF is 1n minus, how many parameters do we have? 1, 2, 3, 4, 5. Okay, so here they have mentioned how many we had, n equal to 13. Okay, so we have 13 observations. So this will be 13 minus 5, that is 8. Alright, and SS residual reduced means we have to take that model where beta 1 is not there. So here beta 1 is not there, is x2, 3, 4. So this one is the SS residual reduced model. So then what do we have here? So this would be, then this would be 73.81 minus, this is 47.86 by 1 divided by 47.86 by 8. So how much does this come to? So this would be 73.81 minus 47.86 is 25.95 by into 8 by 47.86 divided by 47.86. So this is coming to be close to 4.3376, something like this. So I can write it as close, correct to 3 decimal places, 4.338. Alright. So this was how much? This was F1 given this thing f1 given 2 3 4. Okay, so similarly I am going to find out f2 given 1 3 4. All right, from this table. All right, so let me just put these here. All right, so here I have f2 given 1 3 4. So this would be again, so the test statistic would be what? Oh, sorry. Yeah, so the one second. So here if, so then here again the test statistic is how much? This is SS residual of the reduced model minus SS residual of the full model by 1 divided by MS residual. Okay, so this would be SS residual of the reduced model, so it would be 134. So this is the one 50.83 minus SS residual 4 is 47.86 by, since we are testing 4 variable, we are testing actually n minus 5. So this would be 47.86 by 8. Let us find out how much this is. 50.83 minus 47.86 into 8 divided by 47.86. So this comes to 0.499 or close to 0.5. Okay, this is 4.338, this is 0.5. Let me just find out f3 given 1 2 4. So here also the test statistic is SS residual reduced minus SS residual full by MS residual. So this would be reduced model 3 1 2 4, this one 47.97 minus 47.86 by 47.86 by 8. So that comes to so this is 0.018. Right, and then again if I do f4 given 1 2 3, this would be f1 2 3 48.11 minus 47.86 by 47.86 by 8. So this would then be so this is 0.0417. Okay, now the next step is find minimum. So amongst all these I am seeing that if 0.01, this is 0.04, so f3 is the minimum. All right, so minimum is f3 given 1, 2, 4. Okay, and that value is 0.018. Okay, now we have to see if f3 given 1, 2, 4 is less than f out. And how much will that be? This would be f alpha 1, and what is the degrees of freedom of this thing? ms residual, this is 8, so this would be f18. Okay, so this would be upper alpha point of a f18 distribution, this point such that area above this shaded part is 0.05. Okay, because nothing is mentioned, I am going to take 0.05. So let me just find out. So I am here. This is F table for alpha 0.10. This is the F table for alpha 0.05. So let me just take till here. Okay, df1 would be, okay, I'll just take here this thing. Fine. So this is the F table. All right, now we have to see for df1 and 8, this is the criteria. Okay, so df1 and df8, so this is that criteria. So f1 8 0.05 is actually 5.3177. okay, now we see this is 5.3177. so then this holds, this is less than the f out criteria. Okay, so since this is true, this is not significant, therefore we exclude x3 first. All right, so the answer to this question is that at the first iteration x3 will be eliminated. So option 3, option C is actually the correct answer. Okay, so answer is option C, x3 will be eliminated first. Is it okay? Proceeding to the next one. Okay, so now I can, so this is the thing, if you are asked what is the value of the partial f statistic 1 given 2, 3, 4, then that we have already calculated, that is this thing, 1 given 2, 3, 4 is 4.338. okay, so this is 4.338 already calculated. Fine. All right, the next question, the regressor variable that will be eliminated at the second iteration of backward elimination. So now we have already, so now given is that x3 is already eliminated. Okay, so let me just pull up this table here. few more slides here. Cool. Now here they are saying that x3 is already eliminated. Then which is the next variable which should be eliminated, right? So since x3 is already eliminated, x3 is out of the question. So now what do we have? We have beta naught is beta 1 x1 plus beta 2 x2 plus beta 4 x4. So now plus epsilon. So at step 2, here our full model becomes x1, x2, x4. So this then is our full model. Alright. So then df of the full model is n minus 1, 2, 3, 4. So that would be 13 minus 4, that is 9. Alright. Now we have to find out which of the others is getting it will get eliminated next. So then it's the same thing. We have to find out one given 2, 4. That would be SS residual reduced minus SS residual full by MS residual full. So at this step, full model is this one and DF is 9. So this would be SS residual reduced is 1 will be put to 0. So we'll have x2, x4. This is 868.88 minus 47.97 by 47.97 divided by 9. So this would be so this is 154.017, let's say. Okay. Next thing is we have to find out if 2 given 1, 4. That is also the same thing. So this is SS residual reduced minus SS residual full by MS residual full. So this would be SS residual reduced, meaning 2 is set to 0. We have x1, x4. This is 74.76 minus 47.97 by 47.97 by 9. So this comes to so this is something close to 5.026. Okay, and last but not the least, we'll find out f4 given 1, 2. All right, so this is again same thing, reduced full by MS residual. So this is how much? 1 and 2. So this would be 57.90 minus 47.97 by 47.97 by 9. So this is 57.90 minus 47.97 into 9 divided by 47.97. So this is 1.86. All right. Now next what do? We have this, we have this, we have this. So the minimum, next thing is we are doing backward elimination. So then minimum is how much? Minimum is this thing, f4 given 1, 2. That is 1.86. Okay, now we have to check if F4 given 1, 2 is less than the F out criteria. Okay, so F out is how much? F out will be F 0.0519. So let us find out from this table again. So from this table we can see F 0.0519 is 5.1174. It's here. This is 5.1174. So this thing is 5.1174. Oh, no. 5.1174. Okay, so now this is less than this thing, so this is not significant. This is less than this holds true, therefore we eliminate x4 in the next iteration. So then answer is option D. Okay, so then we have option D as the correct answer. Alright, moving on. Alright, now that we have x4, how many did we remove? x4 we have removed, and then in the previous one we have removed x3. Okay, so now we are left with x1 and x2. Okay, now before making any conclusions directly, we would also like to validate that this is the best regression model that remains. Alright, and then it's the same thing, we just take y equal to beta naught plus beta 1x1 plus beta 2x2 plus epsilon. We find out 1 given 2 and f2 given 1. Okay, so in this scenario, again the full model is going to change over here. Okay, so now the full model becomes this thing x1 x2 57.90. so here SS residual of the full model is this 57. This is this thing 57.90. so this would be reduced model. One setting 1 to 0, we have 906.33 minus 57.90 divided by 57.90 by 13 minus 1 to 3, so it would be 10. Okay, and this one would be 1265.68 minus 57.90 by 57.90 by 10. Alright, so here we have how much? This is 906.33 minus 57.90 divided by 5.79. So this is 146 0.53, and this is 1265.68 minus 57.90 divided by 5.97. So this is somewhere 202.31. Alright, and from the previous one we have seen, so now we have to find f. So here now the challenge is to find the minimum. We have found out minimum is which one? Minimum is this one, f1 given 2. Okay, and f1 given 2 is less than, is it less than f out, that is f110 alpha? No, because 110 alpha, this is 4.96, so this is 4.96. So now we see that f1 given 2 is significant and f2 given 1 is also significant because they exceed this threshold of f110 alpha, 4.96. Therefore we can conclude from here that B, x1 x2 is the best model by backward selection. Is it okay? All right. Fine. Let us move on to the next one. Yes. So now we have been asked that, let's say we have an intercept only model. The regressor variable that will be added at the first iteration of forward selection, what would be that? Okay, so let us just pull it up here. Yeah, so now we have, initially we have y equal to beta naught. Okay, and now we want to find out whether we should include x1, x2, x3 or x4. So we could fit x1, we could fit x2, we could fit x3, and we could fit x4. Note that these epsilons are, even though I'm writing it as the same thing, they are not, they won't be same, because different variables will have different errors. Okay, so notationally I'm just writing it as epsilon, because right now I'm not doing any sort of intricate complications where I need to explicitly differentiate them, but bear this in mind, all these epsilons are different because these are different errors. Okay, and the errors are bound to change if you change the variables for your prediction or fitting the regression and so on. Alright, so the regressor that will be added at the first iteration of forward selection is which one? So now we have to find out if 1 given intercept, 2 given intercept, 3 given intercept and 4 given intercept. Right? So then in this case the full model is 1 given intercept. So this is this one. Okay, and the reduced model is that we are setting beta 1 to 0. So this is actually reduced, and these are actually my full models. Alright, and in the full model, the df of the full model is n minus 2. So we would have df as 11. Alright, so now we just need to calculate. So this would be SS residual reduced minus SS residual full. So we have 2715.76 minus 1265.68 by 1265.68 by 11. Okay, so let me just find it out how much this is. Two 715.76 minus 1265.68 divided by into 11 divided by 1265.68. So this comes to 12.60. Here 2715.76 minus 1939.40 into 11 divided by 1939.40. So this would be 4.40. Okay. Okay, and this one will be 2715.76 minus 883.86 into 11 divided by 883.86. So this would be 2715.76 minus 883.86 into 11, divided by 883.86. This would be 22.80. Alright, and we missed one out, that is F2. So here we are going to write it. So F2 given intercept would be SS residual reduced minus SS residual full by MS residual full. So this would be given 0 and 2, 906. So this would be 2715.76 minus 906.33 by 906.33 by 11. So that would be 2715.76 minus 906.33 into 11 divided by 906.33. So this was 21.96. Alright, so here we have, so now the next thing is find out the maximum. Yes, so this is the thing, finding out the maximum. Here again we find that F4 given intercept has the maximum F value, that is 22.88. So therefore this is 22.8 0. Okay, now we have to check if f4 given 1 is greater than f in or not. So f in would be how much? It would be f alpha 1 and df of the full model. So df of the full model is how much? That is 11. Okay, so we are going to find out. Okay, so this is the f table. Alright, so we'll find it out. f1 11 alpha. So f1 df1 here 11 and alpha, this is 4.8443. okay, so this is 4.8443 and we see that this is true. Therefore the first variable that should be included is x4. So the correct option is option D, that is x4 is included first. Alright, so bear this in mind. SS residual reduced minus SS residual full by MS residual of the full model, okay, not the reduced model. Alright, moving on. Yeah, so now that we have, so now given is that x4 is included. x4 is included. Now we have to find out which is the next one that can be added at the second iteration. So we have to find out f1 given 4, f2 given 4, f3 given 4 and then make a decision. So I'll just bring that table up for our own convenience. Okay, yeah, and I'll just write the formula so that I don't get confused. F would be how much? SS residual of reduced minus SS residual of full by MS residual of the full model. Okay, so full model is x1 plus x4, in this case f2 plus f4, in this case f3 plus f4. okay, so in either of the cases the df of the full model would be n minus, so I am keeping x1, x4 and beta naught, so n minus 3, so it would be 10, 13 minus 3. Alright, so now I am just going to find out SS residual reduced, that means 1 is set to 0 and we have 4, so this would be 883.86 minus model with both 1 and 4, so this would be 74.76 by 74.76 by 10. This would be how much? SS residual of reduced model, that is only 4, so this would be 883.86 minus 2 4 together, that is 868.88 by 868.88 by 10. okay, and f3 given 4 would be 3 set to 0, so x4 883.86 minus x3 x4 together, that is 175.73 by 175.73 by 10. So we'll just find it out, each of these. 883.86 minus 74.76 divided by 7.476. So this is 108.23. Okay, the next one is 883.86 minus 868.88 divided by 8.6888. So this is 1.72, and this one is 883.86 minus 175.73 divided by 1 divided by 17.573. So this is 40.29, approximately 40.3. Okay, now what is the next consideration? Next consideration is which is the maximum. This is forward iteration, forward selection. So we'll have to find the maximum one. So maximum is F1 given 4. That is something around 108.23. Now we have to check, is it greater than the F in criteria, that is F alpha 1, and what is the DF? The DF is 10. So we'll have to find out from here. 4.9646 is the criteria. 4.9646. So this holds true. Therefore, we include x1 next. Okay, so then this is the thing, and the answer is option A is the correct option. Alright, so moving on. Now what do we have in the first iteration? What did we add? We added x4. In the second iteration we added x1. Okay, so now what we have to note? We have to note x1 and x4 already added. Okay, now we have to find out which variable would be added at the third iteration, x2 or x3. Okay, so we have to find out x2 given 1 4 and x3 given 1 4. Okay, so we'll just quickly find it out. We'll pull it up here for the sake of convenience. Yeah, there you go. Fine. Now I am going to again be extremely cautious and write it down. So F is SS residual of reduced minus SS residual of full by MS residual of full model. So this one is SS residual reduced is only with x1 and x4. So this is 74.76 minus SS residual of the full model, that means 124. 124 is 47.97 by 47.97 by, okay, so now how many DF of full model would be? DF error DF of full model will be n minus, so we have beta naught x1 x2 sorry x1 x4, so 3 and then one more, so n minus 4. Alright, so this would be 13 minus 4, that is 9. So this would be 9. Okay, and this is x1 x4 is 74.76 minus x1 x3 x4, this is 50.83 by 50.83 by 9. So we'll just calculate this. 74.76 minus 47.97 divided by, into 9 divided by 47.97, this is 5.026, and this one is 74.76 minus 50.83 into 9 divided by 50.83. So this is 4.237. Now the third one is this one, okay, 5.026. So then here maximum, the next step is to find out maximum. So maximum is this one of these two, x2 given 1, 4, that is 5.026. Now we have to check if x2 given 1, 4 is exceeding the f in criteria, which is what? Which is f alpha 1 9, because this is the error df. Okay, so let us just find out from here. That is 5.1174, right? So this is 5.1174. 5.1174. Now this criteria is not matching, so this is false, and hence we stop. Therefore, the regressor variable that will be added at the end of third iteration is none of these. Alright, because x2 is not being added, and if x2 is not significant, x3 is automatically not significant, because we are taking the maximum and seeing whether it is crossing the threshold. So at the end of third iteration, none of these would be added to the model. Is it clear? So then we stop, and the answer is option D, that none of the variables are added further to the model. Is it okay? Fine. Next we move on to the next question. So the best regression model obtained by forward selection involves the following regressor models. So by forward selection, this is where we stop, that is 1 and 4. So answer is A, 1 and 4. Okay, fine. Moving on. So based on the MS residual criteria, which of the following two regressor models do you prefer the most? Okay, so based on MS residual criteria, which of the following two regressor models would you prefer the most? So for this one, what do we have to do? We have to focus on all of these and find out the MS residual criteria for all of these. Okay, so if these are the models, then the DF of the error, or residual, I shouldn't say error, I should say residual df in each of these cases will be n minus 3. 2 regresses plus 1 beta naught. So that is 13 minus 3, that is 10. Alright. So now ms residual for x1, x2 is actually 5.79. Okay. ms residual for x1, x3 is 122.707. Okay. Oh, I don't need to find this out. I need x1, x2, x1, x4. So ms residual x1, x4 is this thing. So this would be 7.476. ms residual for x3, x4 would be 117.573. And finally ms residual for x2, x3 would be 41.544. Okay, so based on this, if ms residual is the criteria, we want to reduce the ms residual. So then we have to select the minimum. So which one has minimum? Minimum is this thing, ms residual x1, x2. Therefore, we would prefer model A with x1, x2. So this is the preferred model, y equals to beta naught plus beta 1 x1 plus beta 2 x2 plus epsilon. So this finally will be our most preferred model. Alright. So with that, we have come to the end of this session. Yes. So I'm going to stop this session now and then I'll see you tomorrow. Alright. If there are any questions, you can post it in the discussion forum. Thank you so much for joining.